Now that you've seen the empirical rule in action, I'd like for you to try these next two on your own. So as always, give that video a pause, try the problems out, and then we'll go through them together. All right, so hopefully you gave these a try. Let's go through and see if we got similar answers here. So assume the lifespan of a tire is normally distributed, so we've got our normal, with a mean of 30,000 kilometers and a standard deviation of 2,000 kilometers. So our distribution name is that capital N for normal, and then I'm going to use 30K for the 30,000 and 2K for the 2,000. And I'll fill in my chart. I'm going to turn it sideways just to get these to fit in here. So 30K, 32K, 34K, and 36K. And then 28K, 26K, and 24K. And then our first question here says 95% of all tires will have a lifespan between blank and blank. So 95% is tied to those two standard deviations. So if I start at that 30 and I go down two standard deviations, that's 26,000, 26K. And then the two standard deviations above will put me at 34K. What percent of the tires will have a life that exceeds 26,000? So exceeds 26,000, there's our 26,000, and I'm interested in this part that is greater than. So 26,000 is tied to two standard deviations below the mean. So we know that with those two standard deviations, that leftover piece is 2.5%. So what I can do is I know the whole thing is 100. If I subtract that 2.5% off, that leaves me with 97.5%. If a company purchased 1,000 tires, how many tires would you expect to last more than 26,000 kilometers? So I'm going to take that 1,000 tires, and then I'm going to multiply it by the percentage that are expected to last that long. So 97.5 would be 0.975. So we get 1,000 times 0.975 gives me 975 of those tires are expected to last longer than this 26,000. Okay, the Oreo cookie problem. So in an Oreo factory, the mass of the cookies is normally distributed with mu equal to 40, so mu is our mean, and for quality control reasons, sigma is equal to 2 grams. So sigma is our standard deviation. Our distribution name here is normal, 40, 2. So if I fill in this graph, I have 40 in the center, 42, 44, 46, and then 38, 36, and 34 on the way down. Cookies are rejected if they weigh more than 44 grams. That would be this part here of the tail, or less than 36 grams. This part here. What percentage of cookies are rejected? So this is within two standard deviations of the mean on both sides. And since it's symmetric like that, that means that we're just interested in this part in the middle, which is 95%. Another way of looking at this is you could look at those tails and say that's 2.5 and that's 2.5. If you subtract both of those from 100, you'll get that 95%. So again, there's a number of different ways to arrive at the right answer, and any of those are fine. How many cookies would you expect to be rejected? Oh, I made a mistake here. This middle is 95%, right? This is why I shade these in, because it makes it a whole lot easier to catch my mistakes. 95% doesn't sound good, right? If we're rejecting cookies, it's rejecting a lot of them. The mistake I made was that I gave the number for the middle. And what I want is the number for these two tails. So I'm going to take 100% and subtract the 95 off, and it's 5% of the cookies that are rejected. Okay, how many cookies would you expect to be rejected in a sample of 10,000? So I'll take that 10,000, and I'll multiply it by 0.05. And so we get that 500 of those cookies we're going to expect to reject. Okay, this last one has, It's a little more difficult, I think, for some people to kind of wrap their head around. So we have some steps here to kind of work through what this means. So it says if 10,000 cookies were produced, how many cookies are within 2 grams of the mean? So we're going to start with what values border 2 grams of the mean. So 40, so if I add 2, I'm here at 42. And then I'm also here at 38. I have those two there. What percentage of cookies are within those 2 grams of the mean? So within means they're close to the mean. So I'm looking at this part here in the center that I have this crosshatch shading on. So within 1 standard deviation of the mean, that's the 68%. And I'm going to write that down so kind of keep track of where I'm at right now. And then if 10,000 cookies are produced, how many cookies are within 2 grams of the mean? So I've got 10,000 times 0.68. And that's going to give me 6,800 cookies. That means 6,800 cookies are really pretty close to what they are actually supposed to be in terms of how the machines are set and what that marketing looks like. All right, so the next question that we're going to look at is, what if I'd asked you how many of those cookies are within 3 grams of the mean? So 3 grams of the mean is going to fall here between these standard deviations. And so what do we do if it doesn't land perfectly on a standard deviation? The answer to that is that we're going to use technology. So come back to the next video and we'll get started on how that technology is going to work.